one question which people frequently have is, we started by saying we need to find out the number of oscillators and the average energy of one oscillator. So here we derived an expression for number of oscillators n0 by 1 minus x, and here we got the total energy. Then to find the average energy per oscillator, again we are dividing it by n. But then again finally we are going to multiply it again by the average energy of one oscillator. So this and this sort of seem to counteract each other's effect. That is a question people often have. So the thing is, if you look at this expression for average energy per oscillator, it is in terms of h, nu, k and t. H and k are constants, nu and t are frequency and temperature, which is what we wanted to derive an expression in terms of. But if you look at this expression, it is in terms of n0 and x. X again is something in terms of h, nu, k, t, but you have an unknown quantity called n0 here, and for n0 you don't have any formula. If you look at n1, n2 and so on, you have a formula for them in terms of n0, but for n0 itself you don't have a formula, and n0 is not a constant either. So this is just an intermediate expression. We derive this only for the purpose of helping us derive this final expression, which is why this will not qualify as the total number of oscillators. So we need to separately find out the total number of oscillators. So why I am explaining this point is because this was the derivation for average energy per oscillator. Now next we will be looking at number of density states, and using that we will be doing something about total energy. So when we do that, people usually come back and ask this question, we already derived something here, why are we doing a totally different thing there? That is because this has a quantity n0 which is ambiguous. It is neither a constant nor do you have a formula for it. So there's no way of calculating n0, and if you don't have n0, you don't know the number of oscillators. So that was just a sort of intermediate value which helps you to calculate this expression. So that cannot be taken as the complete expression. So that was just one point I wanted to clarify there.